Hi there, today I'm just going to show you the proof of the cosine rule. You do not need to know this for level 2 mathematics. However, it is a good example of using what we do know and putting it into something else. So all the maths that I'm going to do is level 2 maths. It's nothing new, it's just some rearranging and putting things into other things. So if you are interested in maths and like to know where things come from, this is for you. You do not have to be able to do this, but just watch and understand. Okay, so when we are looking at our triangle, I've set mine up. Remember, we've got our vertices with uppercase letters, and each of the sides is a lowercase opposite, so B, A, and C. I am going to put in a perpendicular line. So this is at right angles. I'm going to call this X. This little length I'm going to make X at some unknown side. And that would make this length from there to there. If this whole side is B, it'll be B minus X. Okay. Now, we know that we have used Pythagoras already. So I'm just going to write down a few things in terms of Pythagoras because I might need them later. Well, I will need them later. So if I just look at this triangle ABX, a capital X there. This is, I'm going to call H, sorry, the height of the triangle. So ABX, I would have x squared plus h squared equals c squared. And in triangle BCX, this triangle over here, I would have b minus x all squared plus h squared equals a squared. So I've just really written out two Pythagoras's, and now I'm going to just expand this one and see what we get. So this will be b squared minus 2bx plus x squared. You might want to do that. I know this is an area where people get a bit confused, but remember you're just multiplying each of the terms by themselves. And plus h squared equals a squared. So I've just expanded that. Yeah, so what I'm going to do now is get both of those in terms of h squared. So this one is going to be quite easy. That becomes h squared equals, I'm just going to take the x to the other side. And this one, a little bit more to do, but still pretty much the same. So h squared, remember, is the same h we're talking about, so that's all good. H squared is equal to a squared minus b squared. This will be plus 2bx, and that'll be minus x squared. So if h squared equals that and h squared equals that, these two must be equal to each other. So I now have c squared minus x squared is equal to a squared minus b squared plus 2bx minus x squared. Okay, I've got a minus x squared on both sides. So if I took that to the other side, that's actually going to cancel out. So that's quite good that I don't have any x's there. So I'm just going to write this as, I'm going to have my a squared. I want it in terms of a squared because I'm going to be working with this triangle later on, and I'm going to have cos a, and it's the cosine rule, so obviously that's a little trick. Obviously knowing what you're doing helps, but this is how you would apply things. So a squared, and this is going to be c squared, that's going to be plus b squared minus 2bx. Okay, so I've just taken these two terms over to the other side. Okay, now just looking at this triangle over there. So that's all just rearranging. It's just year 9 and 10 stuff, maybe a bit of year 11 in there. Okay, so when we look at this triangle over here, we are now going to say, well, this is the angle A. Okay, so I know that cosine of A is equal to the adjacent side, which is x, over the hypotenuse, which is c. So hopefully you're happy. Adjacent, hypotenuse, it's a right angle triangle. I can just use cos. Okay, cosine. So I am now going to multiply up the c. Now hopefully you can see that I've got an x in here and I've got an x over there, so I can substitute what x is into there. So c squared plus b squared minus 2b c cos a equals a squared. Voila, which is my cosine rule. So just getting two things in terms of each other and substituting in is how we go. As I said, this is not necessary. Oh my gosh, sorry, you didn't see that last little bit that I did there. Sorry about that. This is my c squared plus b squared minus 2b, and then I'm substituting x, which is c cos a, into there, equals a squared. So that is how that is done. QED, as I said, it's not required as a proof, but it is a good thing to know how to do this kind of thing, especially if you're thinking of continuing with mathematics. This is where the joy comes in for me. Have a good day.